There is a $1 powder available at every hardware store and agricultural supplier across the country that can preserve wood for 60 years with a single application. Not a stain that peels within 3 seasons, not a sealant that cracks and needs reapplication every 2 years, not pressure treatment that requires an industrial setup and leaves carcinogenic residue on every board it touches. One application, applied cold with a brush and a bucket on your driveway, and the wood beneath remains structurally sound, free of rot, and resistant to insects 6 decades later. Meanwhile, the wood preservation industry charges between $3 and $8 per linear foot for pressure-treated lumber containing synthetic biocides flagged by the EPA for health and environmental risks since 2003. A $1 powder outperforming that chemistry by decades cannot be allowed to be public knowledge. It was not abandoned because it failed. It was abandoned because it worked too well, leaving an entire industry built on scheduled replacement and repeated chemical treatment without an answer. The wood treatment chemicals market was valued at $38,000 in 2023 and is projected to reach $52,000 by 2031. The average homeowner replacing a standard 6-foot wood privacy fence spends between $1,800 and $4,500 on materials and labor. Industry recommendations suggest replacing wooden fence posts every 10 to 15 years as ground contact rot weakens the structural base. Deckboards need replacement every 15 to 20 years. Each replacement cycle generates revenue for lumberyards, treatment facilities, and construction contractors. A powder that extends the life of wood structures to 60 years does not fit in this replacement cycle economy. It penetrates wood at the cellular level permanently, turning the material into something rot fungi cannot digest and wood-boring insects cannot colonize. This has been happening since Roman engineers first documented its use on harbor timber structures over 2,000 years ago. The suppression of this knowledge is structural. The modern pressure-treated lumber industry emerged after World War II using chromated copper arsenate, CCA, a synthetic wood preservative developed in the 1930s, promoted as the ultimate solution to wood decay. CCA-treated lumber dominated residential construction for 50 years. In 2003, the EPA banned CCA for residential use after studies confirmed arsenic leached from treated wood into soil and onto children's hands at unsafe levels. The industry did not turn to natural alternatives with superior long-term records. It reformulated with alkaline copper quaternary, ACQ, and copper azole compounds, costing more to produce while maintaining the industry's grip on treated lumber. The natural alternative, the $1 powder with a 60-year performance record, was never mentioned in reformulation discussions, industry publications, or EPA guidance. Absence, when maintained consistently, becomes invisibility. Sustained invisibility across 2 generations of builders and homeowners becomes the assumption that no alternative ever existed. Let us return to 65 AD. The Port of Aya, Rome's main harbor on the Tyrrhenian Sea, 14 miles from the empire's center. Roman engineers constructing the timber framework of large warehouses, the halls, to store grain, olive oil, and imported goods flowing through the busiest commercial port in the ancient Mediterranean. The timber is soaked in large stone vats filled with a solution made from crushed mineral dissolved in seawater. The mineral is a blue-green crystalline compound the Romans called chalk canthum, identified by modern chemistry as copper sulfate pentahydrate. Engineering records preserved in the Corpus Inscriptionum Latinarum reference chalk canthum timber treatment and harbor construction accounts from Aya, Puteoli, and Caesarea Maritima. The harbor structures of Ostia, partially excavated beginning in the 19th century, revealed timber pile foundations with measurably lower biological degradation than contemporary untreated timber recovered from the same site. 2,000 years of tidal saltwater biological activity and mechanical stress. The treated timber outlasted the empire that installed it. Move forward to 1767. The British Royal Navy faced a crisis threatening its dominance of global sea trade. Shipworm, Teredo nivalis, was destroying hulls faster than shipyards could replace them. Naval chemists at Portsmouth Dockyard tested dozens of compounds on submerged timber panels in controlled saltwater tanks. Copper sulfate solution applied by saturation treatment before submersion produced the only result that completely stopped shipworm penetration. The compound leached into the cellular structure of the wood, creating a copper-rich environment chemically hostile to every wood-destroying organism tested: shipworm, gribble, rot fungi, and marine bacteria simultaneously. The Admiralty adopted copper treatment for below-waterline timber across the entire fleet. In 1832, French railway engineer Boucherie developed the first systematic industrial application: a sap replacement process where freshly cut green timber was fitted with a pressurized reservoir of copper sulfate solution that drove the compound through natural sap channels across the entire cross-section of the timber. Railway sleepers treated with the Boucherie process, installed across the French and Belgian rail networks in the 1840s, showed documented service life of 40 to 60 years in ground contact. identical to what the University of Oregon researcher found in that Pacific Northwest fence post in 2024. 190 years of documented performance data. The wood treatment chemicals industry built its modern business on synthetic alternatives that cost more, perform for shorter periods, and carry documented health and environmental risks that copper sulfate, when used at correct concentrations, does not. Before showing the exact chemistry, application protocol, and the molecular mechanism by which copper ions permanently restructure wood cell walls against biological attack, the industry ensures this information remains out of public hands. Copper sulfate solution penetrates wood at the molecular level. Wood decay is caused by two primary biological agents. Lignin-digesting fungi break down the structural polymer matrix of wood cell walls, and wood-boring insects, termites, powder post beetles, and carpenter ants excavate galleries through wood fiber. Both require the same cellular entry point, the pit membranes of wood cells, microscopic openings connecting adjacent cells, and allowing organisms to move through the wood's internal structure. Copper sulfate solution, at a concentration of 1.5% by weight, penetrates these pit membranes through capillary action and diffusion. As the water carrier evaporates, copper ions bond permanently to the cellulose and lignin polymer chains of the cell wall through coordination, forming a stable complex with the hydroxyl groups of the wood polymer and incorporating into the molecular structure of the cell wall. Lignin-digesting fungi produce enzymes, primarily lacases and peroxidases, that break down normal wood cell walls. These enzymes are irreversibly inhibited by copper ions at concentrations of 50 to 200 parts per million, levels that copper sulfate treatment delivers throughout the entire treated volume of wood. The fungi cannot digest copper-chelated lignin. The wood becomes biologically indigestible. A 2011 study published in the International Biodeterioration and Biodegradation Journal confirmed that timber treated with 1.5% copper sulfate solution showed zero fungal penetration after 25 years of accelerated laboratory decay testing, equivalent to 60 years of outdoor ground contact exposure. Wood-boring insects avoid copper-treated wood through chemical detection. The copper ion concentration disrupts pheromone trails used by termites and carpenter ants to communicate gallery locations. Copper-altered lignin does not produce volatile organic compounds that wood-boring beetles use to locate suitable nesting timber. Step 1. Purchase copper sulfate pentahydrate crystals, sold as root killer, algicide, or agricultural fungicide from any hardware store or agricultural supplier. A 1-pound bag costs between $6 and $10 and treats approximately 50 linear feet of fence posts or 200 square feet of decking. Step 2. Dissolve the crystals in warm water at 1.5% concentration, roughly 1 teaspoon per liter of water, stirring until the solution is completely clear blue. Use plastic or glass containers only. Copper sulfate reacts with iron and galvanized metal. Step 3. Treat green or freshly cut timber before it dries for maximum penetration. Green wood retains open sap channels that allow the copper solution to travel deep into the timber by capillary action. Step 4. For posts, submerge the ground contact portion, the bottom 18 to 24 inches, in copper sulfate solution for at least 24 hours. For boards and dimensional lumber, apply generously with a brush or roller across all surfaces. Allow 30 minutes for absorption, then apply a second coat. Step 6. For existing installed structures, drill half-inch holes at 6-inch intervals along each border post and inject copper sulfate solution directly using a squeeze bottle. The solution diffuses outward through the wood cellular network over 24 to 48 hours. Total material cost for treating a standard 150 linear foot privacy fence is under $25 in copper sulfate crystals. The industry cost for the same fence using pressure-treated ACQ lumber is $800 to $1,400 in materials before installation, with replacement needed in 15 years. Over 60 years of ownership, the pressure-treated replacement cycle costs between $3,200 and $5,600. Copper sulfate treatment costs $25 once and never needs repeating. Safety note: copper sulfate is toxic to aquatic organisms at elevated concentrations. Do not apply near ponds or drainage channels leading to water bodies. Wear gloves and eye protection when mixing and applying. Keep children and pets away until wood has fully dried. Now you know what every contractor quoting pressure-treated lumber replacement has never mentioned. The powder Roman harbor engineers dissolved in seawater 2,000 years ago, adopted by the British Royal Navy as fleet policy in 1767, proven by French railway sleepers across 60 years of ground contact service, and confirmed by a 2011 peer-reviewed study to deliver 6 decades of documented protection, is available at your hardware store right now for less than the cost of a single pressure-treated fence post. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.